Today we're going to look at solving rational equations. The objective today will be to find the value of x. Most likely we'll be finding the one value of x. There might be problems where we'll have to solve for two values of x, but our equations today will have fractions. And our primary goal before we actually get to solving for x will be to try to get rid of the denominators so that it makes it easier to solve the equations. One of the important things that we're going to need to do is to identify the least common denominator. Sometimes it's called the least common multiple. This is the smallest possible value that we can multiply to a fraction that will cancel out the denominator. So here's an example. X over 4 plus 1/2 equals 5 over 24. We've got three fractions, three denominators, 4, 2, and 24. We want a magic number that will cancel all three denominator values. So it's got to be the smallest common multiple that will do the trick. So looking at the largest value there in the list, 24, nothing smaller than 24 will be able to cancel 24. 24 actually will also cancel 4 because 4 goes into it 6 times. It will also cancel 2 because that goes into it 12 times. So in this example, 24 is the least common multiple or the least common denominator. So what we're going to have to do is actually multiply the entire equation by 24 over 1. So when I distribute this value here, this least common value gets multiplied to every value in the equation, whether it's a fraction or not. So here we've got all fractions. Some equations might not have all fractions, but regardless, this magic multiplier that we're using has to multiply to every value. So once you distribute it, you basically do the reducing, canceling trick we've been doing earlier this chapter, and then you multiply to get a value, a new value for your equation. So cancel, multiply, 12 times 1, cancel, multiply, and now we've gotten rid of the denominators and we can proceed to solve. So subtract 12, divide by 6, our answer will be -7/6. Here's another example, hunting for our least common multiple. Our denominators are 7, 2, and 3. And obviously we can't pick a value smaller than the biggest value there, so it's got to be a value bigger than 7 for the 7 to divide into. And often, or I should say sometimes what happens is the least common denominator is basically the product of all three values. And sometimes you don't know this, and if you have to, then you take, you've got to multiply everything out and use that as your least common value. So this will be 7 times 6, which is 42, and that becomes our common multiple or common denominator, which just means it's our magic number that we're going to multiply to the equation. So distribute the multiplier. Go through and cancel your denominators. Multiply what's remaining, 6 times x, 21 times 1, 14 times 2, and then solve for x. So subtract 21, divide by 6, we get 7/6 as the answer. If you have great difficulty trying to think of the one magic number, sometimes you can go the long way of doing the problem, which is just get rid of each denominator one at a time. So how does that work? So that would just work as going left to right. I get rid of the 7 in the denominator, which means I'm multiplying the whole equation by 7. So I distribute the 7 to each value, and then I cancel this 7, and then cancel anything else I can, but I can't because 2 will not cancel, 3 will not cancel, so I really will only get rid of the first denominator. So that result will give me x plus 7 halves equals 14 thirds. Then I get rid of the next denominator, which is 2, so I multiply by 2 over 1 to each value in the equation. I distribute the value 2 to each value in the equation, and then I'm going to reduce and multiply. So after getting rid of 2, I'm left with 2x plus 7 equals 28 over 3. And now I'm going to need to get rid of 3. So then now 3 is the multiplier. I multiply, multiply, multiply. Then I'm going to cancel these 3's and continue to simplify the equation and then eventually solve for x. And so after getting rid of 3, we now have the equation 6x plus 21 equals 28, which is just like the result after multiplying the 42 in the previous problem. And I'm not going to finish solving, but you see how the 42 just makes it faster to do instead of step by step by step each denominator at a time. But that you can still use in an emergency case if you can't figure out your LCD right from the start. Here is the process we will follow to solve rational equations. So as we've been doing all chapter long, we get a factor, specifically the denominators for these problems. You're going to want to identify your excluded values because you don't want these coming up as solutions at the end of all your work. Otherwise, when we're down at step 6, we're going to have to reject the solution. Step 3 is finding the least common multiple or the least common denominator. Step 4 would be to distribute and multiply this LCD, and at the end of this step we'll be getting rid of all the denominators. Then we're ready for step 5, which is solve for the variable. The solving could take 2 paths here. We could solve just a traditional algebra 1, x to the 1, isolate the variable, and so on. Or if we have an x squared, which is going to become just like solving a quadratic. So using factoring or the quadratic formula is what we'd have to do in those cases. Checking the solution is the final step, and again here you're reflecting back to step 2, the excluded values, reject any solutions that are excluded, and state if there is no solution for the problem. Here's the first problem we'll look at. 5 over x plus 3/5 equals 2 over x. We have no polynomials in the denominator, therefore we have no factoring to do for the factoring step. We identify the restricted or excluded values. That's what makes this denominator and this denominator 0, so that's actually at x equals 0. The least common denominator will be the multiplier that will get rid of the x down here and the 5 down here, so that means we're going to have to use the least common multiple 5x, and that's what we're going to multiply to everything in the equation. So in this step we're distributing the least common denominator value, and then after that we would cancel the denominator to what it goes to into the numerator. So this guy cancels this cancels that, this x cancels this x, and now we need to multiply the numbers on the top. So after multiplying we get 25 plus 3x equals 10. And now we're ready to solve for x. So isolating x, subtracting 25, dividing by 3, we get -5. We have to go back and check to see, is this an excluded value? And it is not. So therefore we can call this our solution to the problem. Here's another example. This time we've got some polynomials in the denominator. They do not require factoring, however, so we're going to now investigate and find the excluded values. For the first denominator, the excluded value is -2, and for the second denominator, it's +5. The least common denominator will be the groups that will cancel this and the group that will cancel this, which means our LCD is one of each of those groups. So we write this as a product, and that will be our multiplier for the next step. So again, that LCD is going to multiply to each of these ratios, and then we cancel the groups that will cancel each other out. So the x plus 2's cancel, the x minus 5's can't cancel, and then we have to multiply what's remaining. So multiplying here, we'll have to distribute the 7 into that group, 7x minus 35. We have to distribute the 6 into this group, giving us 6x plus 12, and now we solve for x. So isolating x, I brought the 6x over to get 1x on the left. Add 35 to the 12, we get 47. We're actually done solving for x because we're at 1x equals 47. And we have to check if this value is restricted or excluded. And it is not, so we can call it our solution.